All right, this next lesson is solving quadratics through factoring. So solving quadratics, when looking for a solution, you're looking for the x-intercept. So that's when your y value is 0. So this means every time I ask you guys to solve a quadratic, you have to set that equation equal to 0. There's multiple ways to solve quadratics. There's factoring, taking the square root, the quadratic equation, long division, etc. But obviously today in this unit, we're just really going to look at factoring. These are 4 names that you need to know. They mean the exact same thing. So you'll notice all your directions will either say find the x-intercepts, find the solutions, find the roots, find the zeros. For all of those, I'm really just telling you to do this same thing I'm about to show you. All right, so your first example says find the roots of the quadratic equation. So remember, this is solving quadratics through factoring. We took notes before that said your equation has to be set equal to 0. It is. So I can just go ahead and start factoring. I look, my a value is not negative, and there's nothing that divides 1, -2, and -3. So I can just start labeling A, B, and C and creating the star. So A is 1, B is -2, C is -3. So when I go to fill in the star, I have A times C on top and B on bottom, A on the 2 sides. If I'm looking for 2 numbers that multiply to get -3, but add to get -2, I know that that's -3 times +1. So then I have x minus 3 and x plus 1, and again I bring down the equals 0. So the reason I can't just solve this normally is because I have x squared and a regular x in the original equation. Once I factor it down, I break apart those 2 x's, and now I have 2 completely separate equations. So I can take, well, x minus 3 equals 0 and x plus 1 equals 0. And this is where I come up with my solutions. So if I solve both equations, I'll get x equals 3 and x equals -1. So this is my solutions, or the roots, the zeros, the x-intercepts to this quadratic. The reason I included this graph over here, this is actually the graph that goes with that equation. And if you notice, the 2 x-intercepts are at -1 and +3. So we're going to see that today, where your solutions are the same as your x-intercepts on your graph. So here's 2 more examples I'm going to do with you. This first one, it's 3x squared minus 15x plus 18. Again, we wrote in the first set of notes that it has to be set equal to 0. So since I have an f of x here, I'm just going to put 0 equals 3x squared minus 15x plus 18. Remember, f of x just means function, so we're setting the function equal to 0. When I go through here, my a value is not negative, but I can divide every single term by 3. So when I divide the first term by 3, that leaves me with x squared, then -5x, and 6. So I have 0 equals 3 parentheses, x squared minus 5x plus 6. Your equals 0 and your greatest common factor have to carry through to the end of the problem. All right, so I have A is 1, B is -5, and C is 6. So I have 6 on top, -5 on bottom, and 1 on the sides. My 2 numbers that can multiply to +6 but add to -5, that's going to be -2 and -3. So I have 0 equals 3 parentheses x minus 2 and x minus 3. All right, this next piece is going to seem a little funny. Why won't it let me slide? There it goes. Okay, sorry. This next piece I show you is going to seem a little funny, but I promise if you get in the hang of it now, it's going to make a unit from now a lot easier. So now that I have it factored, I'm going to set all 3 things that I'm multiplying together equal to 0. So again, setting this greatest common factor equal to 0 seems weird, but if you get used to it now, there is a time where that actually means something, so you're going to have to do it eventually. So if you get in the hang of doing that now, it'll help out. But I know that 0 can never equal 3. There's no way for that to happen, so it can go away. Then I solve for x to get x equals 2. And if I solve here, I'll get x equals 3. So the x-intercepts, or the zeros root solutions, to this quadratic is x equals 2 and x equals 3. All right, the last example I'm going to do with you, I have 2x squared minus 7 equals negative 13x. So the first issue I notice here is that it's not set equal to 0. Instead, it's set equal to a negative 13x. So to get rid of this, I need to add 13x to both sides, and that will give me 0. So these will cancel out to 0 equals. There's nothing to add a plain x to, so I'm just going to write it all in order. So I have 2x squared plus 13x minus 7. So notice I kept it in order, so I still have that standard form of ax squared plus bx plus c. If I look at my three terms, my a value is not negative. There's nothing I can divide all three numbers by, so I'm going to go ahead and just say a equals 2, b equals 13, and c equals negative 7. So that gives me a times c on top, b on bottom, and a on the two sides. So if I'm thinking of two numbers that multiply to negative 14, but add to 13, the only thing that could possibly work is positive 14 and negative 1. If I look here, and I've kind of been skipping this step because it hasn't happened so far, but I can reduce one of my sides. So when I go to write my problem, I have x plus 7 and 2x minus 1 equals 0. So I set each factor equal to 0 and solve for x. Oops, so I get x equals negative 7. Sorry, it's getting a little blurry down there. On this other one, I can add 1 to both sides to get 2x equals 1. And then this is the first one where there's a two-step, and we actually get x equals 1/2. A fraction is okay. That does not mean it's wrong. So my two x-intercepts here are negative 7 and positive 1/2. All right, now that we did all of that factoring and solving, here is where the next part that'll be on your homework. Here I say write a quadratic in standard form given the solutions. So remember, the solutions, another word for that is x-intercepts. So what this problem is asking you to do, it's asking you to find the quadratic that has the x-intercepts of 5 and negative 2. So if I think back, well, I've always had my factors. And so this would be like x equals 5 and x equals negative 2. Well, when I go to solve, I use my inverse operations. So I would have to do, to get an answer of positive 5, my factor would have had to have been x minus 5. And then to get an answer of negative 2, I would have had to have x plus 2. So this is where we're going to start working backwards. Normally we start with the quadratic, factor it, and solve it to get our x-intercepts. So now I'm going to do the opposite. I'm going to start with my x-intercepts. I'm going to write it as factors, but then I'm going to multiply them together. So if you prefer the box method, do that. If you prefer FOIL, do that. This first one, I'm just going to FOIL. My pen has stopped working. This is really cool. There we go. So that's x squared plus 2x. And then this gives me negative 5x and negative 10. So I have x squared minus 3x minus 10. So this is the quadratic that has its x-intercepts at 5 and negative 2. All right, I'm going to do one more of these examples for you guys. So again, find the quadratic that has the solutions -2 and 10. So this is the same as saying, well, x equals -2 and x equals 10. So the factors that I need to deal with is x plus 2, because then I would subtract 2 to both sides, and x minus 10, because if it's a minus, then you would add to solve. I'll do the box method for this one. So I'm going to line one side with x plus 2 and x minus 10. So x times x is x squared. X times 2 is 2x. X times -10 is -10x. And -10 times 2 is -20. So I combine my like terms to get x squared minus 8x minus 20. So again, that is the quadratic that would give me the 2x intercepts they're looking for. Okay, so these are your try on your own problems. This is where I'm going to stop you and you have to answer the questions that puzzle. Again, your answers get sent back to me. I will look at them, mark them right or wrong, give you any comments, and then we'll go over these problems the next time I see you. All right, before you get your homework, I am going to have you do this worksheet first. This connects solving through factoring and graphing kind of together. So I'm going to start with factoring. So I have x squared plus 6x plus 5 equals 0. There's no greatest common factor. I know that a is 1, b is 6, and c is 5. So my two numbers that multiply to 5 but add to 6 is just 5 and 1. So that tells me my factors are x plus 5 and x plus 1. So remember, we're going to set those apart and set them each equal to 0. So that when I go to solve, I'm left with x equals -5 and x equals -1. So these two solutions, I know I want them in my table. So I'm going to start at -5. So if I go -5 in the first one, -4, -3, -2, and -1. So this one works where I can count by ones, but on your next tables, look to make sure, is it going to be better in your tables if you count by 2 on the x values, if you count by half, or whatever. You want to have both of your solutions showing in your table. Well, I know here that so once I have my table filled in, this is where I need to fill in the y value. So I'm going to take this value of -5, using parentheses, I'm going to plug it into this equation. So you use your calculator in parentheses. When you plug all the x values into the equation, your answer should be 0, -3, -4, -3, and 0. So when you go to graph this, I go to -5, 0, and put a point there. I'm at -4, -3. I'm at -3, -4, -2, -3, and then -1, 0. And then I can draw my graph. And of course, yours should look 80 times better than mine. So what you should notice every single time is the y value for your solution should always be 0, because remember, those are your x-intercepts as we see here and here. So you should connect your solutions to your graph and through your factoring. So you have 4 more like this to do. Once you finish this, show this completed worksheet to the sub, and then you'll get the homework.